Write an algorithm or flowchart to solve the following pair of equations for x and y. In case 1, we will apply Gauss elimination method, that is R2 is equals to R2 minus R1 into A21 upon A11. By solving this, we will get the value of x1 is equals to minus 32.79451 and x2 is equal to 16.9589. In case 2, the value of x1 is equal to minus 23.7959 and x2 is equal to 12.63265. In case 3, the value of x1 is equal to 2 and x2 is equal to 0.9998. In case 4, the value of x1 is equal to 2 and x2 is equal to 0.99998. In A part, we have to compare case 1 and case 2. Hence, we can conclude that when the value of A2 is changed by 0.0001, then the result displays a big change in their x1 and x2 values. In case 2, we have to compare case 3 and case 4. Hence, we can conclude that interchange of equation does not affect the solution of case 3 and case 4. Question number 2. Consider the quadratic equation x square plus 2x minus 2 is equal to 0 and obtain the root and floating point with 4 digits in mantissa. We'll solve this by using Newton-Raphson method. F dash x is equal to 2x plus 2. So the root lies between 0, 1 and minus 3, minus 2. For the roots between 0, 1, the first root is 0.7320 and for roots between minus 3, minus 2, another root is minus 2,73205. In case 1, we will substitute the value of root 1 and find the value of x1 and x2, and in case 2 also we will substitute the value of another root and find the value of x1 and x2. In both the cases, we have substituted the roots and can conclude that the answer of both the cases are different. Question number 3. How are polynomials represented in computers? Write an algorithm or flowchart to evaluate polynomial. There are various ways to store a polynomial, such as arrays or linked list. The algorithm for the polynomial is as follows. A. Evaluation of polynomial by brute force technique is simple but involves n into n plus 1 by 2 multiplication and n additions. The algorithm which follows the number of multiplication is reduced to n. The algorithm is based on the following alternate methods of writing the expression. B. Consider dividing a polynomial where r is the root of the original polynomial. Here we will find the reduced polynomial, that is as follows, and then evaluating the coefficient of polynomial with quotient obtained by division, what we will get. The algorithm is as follows for I is equals to 0 to n in steps of 1 to. Second, read a and for. Third, bn minus 1 is equals to an. Fourth, for a is equals to 1 to n minus 1 in steps of 1 do. Fifth, bn minus 1 plus I is equals to an minus I plus r bn minus I. And for 6, for I is equals to 1 to n minus 1 in steps of 1 do write bi, and for 8th stop. Question number 4. Compare the iterative methods of root finding with comments on reliability of convergence. Bisection method, m is equals to a plus b by 2, order of convergence is 1 and it guarantees convergence. False position method, m is equals to a into f of b minus b into f of a upon f of b minus f of a. Order of convergence is 1 and it guarantees convergence. Secant method, m is equals to a into f of b minus b into f of a upon f of b minus f of a. Order of convergence is 1.6180 and it does not guarantee convergence if roots are not near. Newton-Raphson method, m is equals to b minus f of b upon f dash b. Order of convergence is 2 and it converges very fast. Successive approximation, xi is equals to g of xi minus 1. Order of convergence is 1. It is easy to program and it does not guarantee order of convergence. Question number 5. Write an algorithm or flowchart for Newton forward difference interpolation. We'll write algorithm for it. 1. Start. 2nd. Read n. 3rd. For I is equals to 0 to n minus 1, read xi, yi and for. 4. For j is equals to 1 to n minus 1, for I is equals to 0 to n minus 1 minus j, yij is equals to y I1 I plus 1 j minus 1 minus yi j minus 1 and for. 5th, for I is equals to 0 to n minus 1, for j is equals to 0 to n minus 1 minus I, print yij and for. 6th, read a. 7th, h is equals to x1 minus x0. U is equals to 8th, u is equals to a minus x of 0 upon h. Sum is equals to y of 0 and p is equals to 1.0. 10th, for j is equals to 1 to n minus 1, p is equals to p into u minus j plus 1 upon j. Sum is equals to sum plus p into y of 0 j. And for 11th, display a and sum. Stop.